Hello everyone! ListAgg is an Oracle SQL function used to aggregate data from multiple rows into a single string. Here are some examples to demonstrate how this construct works. Starting from Oracle version 19, ListAgg can be used without the within group clause. Let's begin with the simplest syntax variant where everything is set to default and the order of data concatenation is not important. In this example, ListAgg works as a single set aggregate function which operates on all rows and returns a single output row. As an input parameter, you can pass either a column name or an arbitrary expression. Let's explore passing a column with an integer type. You can see that null values are ignored during concatenation. By default, duplicates are not suppressed, and the elements are concatenated without a delimiter. With this construction, you cannot rely on the order in which the concatenation will occur. The slide also presents the actual query plan. In Oracle, there are many constructs that are essentially syntactic sugar, meaning they are easy to read and understand, but Oracle transforms them before execution, which is important to understand for proper query optimization. In this case, Oracle automatically converted the numeric type to a string using toChar and add null as a delimiter. Replacing the default values with explicit ones, this construct would look as follows. Instruction all and null as delimiter are used by default in ListAgg. Note how Oracle transforms the query. There is no all. To suppress duplicates, you need to explicitly specify the distinct instruction. Sorting in the main query cannot define the order in which the concatenation occurs within ListAgg. In this example, ListAgg works as a group set aggregate function operating on and returning an output row for each group defined by the group by clause. To suppress duplicates, you need to explicitly specify the distinct instruction and the suppression will occur within each group. Note that Oracle sorted the element being concatenated during suppression, but you should not rely on this sorting. If you need to sort the element being concatenated, you must explicitly specify order by within ListAgg. We will look at such examples next. In this example, ListAgg works as an analytic function. ListAgg partitions the query result set into groups based on one or more expressions in the query partition clause. In the partition by section, we can specify column names or expressions separated by commas, and as a result, ListAgg will concatenate elements within these virtual groups. Note the bug that appears in Oracle version 19. The documentation states that field in the partition by section can be specified within parentheses and separated by commas, but this doesn't actually work. For ListAgg used as an analytic function, here is an example query execution plan. To suppress duplicates, you need to explicitly specify the distinct instruction, and for each row within the group specified in partition by, the suppression will occur. In summary, ListAgg can be used as a single set aggregate function, as a group set aggregate function, and as an analytic function. Subsequent examples will be shown for ListAgg as a single set aggregate function, but they apply to both LISTAGG as a group set aggregate function and LISTAGG as an analytic function. The output of the LISTAGG function is a string, but the elements that compose it can have various types. For example, number, date, timestamp. If the expression we want to concatenate using LISTAGG are not strings, it's advisable to explicitly convert them using tochar. Otherwise, Oracle will implicitly perform such conversion, which will depend on the NLS parameters for the current Oracle session. In this example, we can see that the delimiter for the element in LISTAGG matched the decimal separator in NLS numeric characters. NLS parameters for the session are inherited from the client's connection to Oracle. This means that if you don't explicitly specify the conversion format in LISTAGG, client connecting from different regions, for example Europe, America, Japan, will see different LISTAGG results. This issue is particularly evident for date and timestamp types. In LISTAGG, you can specify a delimiter to be used when concatenating elements. The delimiter can be multi-character. LISTAGG skips empty elements, meaning the delimiter is not added after them. The delimiter is added between non-empty elements being concatenated. So there will be no delimiter at the beginning and end of the resulting string. There are SQL and PL/SQL implementation of the LISTAGG function. In SQL implementations, the delimiter needs to be explicitly specified and cannot be directly read, for example, from a configuration table. As a workaround, the delimiter can be obtained from a context variable or from a PL/SQL function. In PL/SQL implementation, the delimiter can be specified using variables. Next, let's consider the possibility of sorting element aggregating within LISTAGG. If you specify the order by clause, you must also specify within group and vice versa. These two clauses must be specified together or not at all. I will show examples of sorting for LISTAGG as a single set aggregate function, which are applicable to both LISTAGG as a group set aggregate and LISTAGG as an analytic function. By default, sorting is applied in ascending order. The ask instruction function has a sorting hint, but Oracle removes it from the actual query. Example of sorting in descending order. Example of sorting in ascending order with duplicate suppression. Example of sorting in descending order with duplicate suppression. You can sort not only by fields from the table, but also by expressions. For example, first output even numbers, then odd numbers. In sorting conditions, you can also specify fields and expressions from the main query, and sorting parameters such as nulls first and nulls last may apply to them. Next, let's consider how the LISTAGG function behaves when the return values exceeds the maximum length of the return data type. The maximum length depends on the database initialization parameter, max string size. Starting from Oracle 20, it becomes possible to upgrade the database by setting max string size to extended. But most databases still operate with max string size equals standard. In these examples, we'll consider a database where max string size equals standard. For example, let's consider the concatenation of series of consecutive numbers separated by comma. Without an error, you can output numbers from 1 to 1021. After concatenating the number 1021, the resulting string will have a length of 3997 bytes. There are still 3 bytes left until the 4000 byte limit. But since we have a series of consecutive numbers, the next number 1022 will not fully fit. By default, LISTAGG operates in the on-overflow error mode. This construction can be specified explicitly, but before executing the query, Oracle will remove it as redundant. When concatenating the next number, we get an error. Using the on-overflow truncate construction, you can avoid the error. By default, the truncation indicator is an ellipsis. After the truncation indicator, the database appends the number of truncated values enclosed in parentheses. The database truncates enough measure values to allow space in the return value for a final delimiter, the truncation indicator, and 24 characters for the number value enclosed in parentheses. With the delimiter equal to comma and the truncation indicator equal to ellipses, the maximum allowable length of the resulting string will be 3970. We see that with this length, the number 1016 no longer fully fits, and therefore, starting from it, the subsequent 7 elements are truncated. The actual query execution plan shows that if the default withCount construction is not specified, Oracle will add it automatically. The truncation indicator can be arbitrary. Example, where the truncation indicator is truncated count of items. The truncation indicator can also be an empty string. With the distinct instruction, duplicates are suppressed first and then aggregated into a string. If you specify without count, then the database omits the number of truncated values from the return value. In this case, the database truncates enough measure values to allow space in the return value for a final delimiter and the truncation indicator. Values that are aggregated can also contain multi-byte characters. Multi-byte characters can also be present in the delimiter and truncation indicator. For example, let's aggregate characters of the Greek alphabet, where each character is 2 bytes. We will specify 4-byte characters as delimiters. I want to emphasize again that the maximum length of the string being aggregated is always in bytes. However, character strings that can contain multi-byte characters are concatenated. If the string being aggregated causes the aggregation result to exceed the maximum allowable bytes, then the entire aggregated string and the following strings are truncated. If the on-overflow truncate construction is not specified, an error will occur. You can also use LISTAGG together with having instruction. I'll show you how I checked all the test cases with a script. That's all. Thanks for your attention. See you again. Bye everyone.